be good.
Sorry, completely forgot. All right, there we go. Shoot, forgot my news to record, but anyway, here we go. Recording now.
All right, so this presentation is called 10 Things I Wish I Knew When I Started Using Git, and it's kind of meant to be, unfortunately, for you guys, a little bit more advanced. It's some of the things that I realized after using Git for a few years that made my life a lot easier that I wish I would have figured out when I started. So hopefully you guys can kind of follow along, and maybe I'll convince you guys all that you should all start using Git or something like that. So I have my own company out in Golden, Colorado called SAS Workshops. We have a website, sasworkshops.com. If you go check it out, we have a blog on there. Our main goal is to help other LabVIEW developers improve their skills. So, you know, a lot of LabVIEW developers just go out there and are like LabVIEW gun for hired. We tend to try to work with other people who are already doing LabVIEW and help them do it better. We have our blog. We run some workshops. We have a unit testing workshop, and I were talking earlier about unit testing. We have an online course called Using Git Effectively, which is kind of related to this. A lot of the stuff that I'm going to cover here comes from that. We have a mastermind group where we get together twice a month and share ideas. And then we just do some general consulting. Sometimes I just write code. Sometimes, like, some of the things I really like doing are writing scripting tools to help people be more efficient with things. So and automate part of their development process. Let me move this. Hold on, I gotta figure out how to move this bar because it's kind of in the way. There we go. Cool, put that out of the way. One second. I guess I'll show the videos. Just keep that off the side. So the assumption here is that most of you are at least familiar with version control and know what it is, right? And I've hopefully heard of Git and/or SVN. I think this presentation is probably most useful for people who are using SVN and are thinking about switching to Git. It's going to give you a lot of tips and tricks for making that really easily. Because I used to use SVN, as Greg mentioned, back in the day, like 10 years ago, it was the standard. And it's kind of been replaced by Git by now, but there's still plenty of people still using SVN. If you're still using SVN, it's better than nothing. It certainly works. And, you know, if it works, and, you know, you don't necessarily need to change something that works, but I do think Git has a bunch of advantages. The goal of this presentation is to highlight some important things about Git that are not immediately obvious, or that maybe took me a little while to figure out. Using Git is very complicated. If you've tried to use it, you will know exactly what I mean. And so there's a lot of obvious things that I'm not going to cover just because they're covered in a lot of other places, a lot of the NI literature and stuff. So why use Git, right? So I mentioned that Git has some advantages. To me, the number one advantage, I work as a contractor, and often I end up on customer sites and they have either crappy or spotty Wi-Fi or crappy or spotty internet access. And so with SVN, you have this centralized server model where you have to connect to the centralized server to do anything. And if you can't connect, you can edit your working copy in your code, but you can't check things in or out, and you can't look at the logs or do any of that stuff. With the Git model, it's very different. It's kind of distributed. So everybody has their own copy of the repository, and you have I don't know what the term is, a centralized one that everybody syncs to that resides on like GitLab or GitHub or Bitbucket or something. But you can make all the changes you want to your local repository anytime you want without connecting to the internet. So you can be on a customer site and you can make commits and you can roll stuff back. And you can look through the history and do all of that. And then in the evening or whenever you get back to the office, you sync everything up and everybody's happy. So that to me is the number one advantage of Git that is immediately obvious. There are some other advantages, actually. One of the other advantages is it's very quick. Git can be SVN can be very slow, right? Because you're doing everything over the network. Git, every time you check something in or pull something out, you're doing it locally, unless you specifically want to sync with the remote repository. So it limits the network traffic, and since everything's local, it's really quick. Oops. All right, so the first thing I'm going to say about Git is it took me a while, but don't be afraid of the command line. So I know most of us are LabVIEW programmers. We like our fancy pictures. We don't like lines of text. That's why we're LabVIEW programmers and not C programmers or something. But there are some advantages to knowing a little bit about the CLI and being able to use it. So the first thing is, why are there so many GUIs for Git? If you go online and you go to this website, the Git website, and you look up the number of GUIs, there are 41 different GUIs for Git. And if you think about that, that ought to tell you something. That means 41 people decided that this is too hard to use. I'm going to try to make it easier by making this GUI. And the fact that there's that many of them and there's so many pages of help and questions on Stack Overflow should lead you to the conclusion that it's not you. If you've tried to use Git and you found it hard to use, it is very hard to use because it was designed to be very flexible and not necessarily user-friendly. And they did a very good job at making it flexible. They did not put much effort into making it user-friendly and easy to use. They've recognized that, and it's gotten better over the years. So the past couple of years, they've had some releases where they've added some features. They've made the help more useful. They've added some commands to kind of simplify some things, some common things that you might want to do. So Dan, are you monitoring the chat if somebody throws stuff in the chat?
Oh, yeah.
Okay, cool.
Yeah,
right.
there's people, you know, just said Tortoise Svn or Git, what they were using.
So there's a bunch of people. So there's some people using Git. Okay, cool.
Mm-hmm. Yeah, there's like, yeah, I think that's pretty sprinkled, you know. Yeah, there's some people using Tortoise Svn, some people using Git. So, you know,
David made another important point too. Distributed models protect against ransomware and other problems, like if your server crashes or something, because right in SVN you had this centralized server that was the one copy, and in Git everybody has a copy. So if the centralized server goes down, everybody's still got a copy, and then you can figure out how to recover it a lot easier. So that is a useful thing. So here are just some of the Git GUIs on the right here. Source tree is really popular because it's free. It's made by Bitbucket. It's probably the most popular. GitHub has a desktop version. There's something called Git extensions. Excuse me. There's something called Git fork and Git Kraken. I use Git Kraken sometimes when I want to use a GUI. There is Tortoise Git. Those of you who are from SVN world will remember Tortoise Svn. So Tortoise Svn was like a thing that you installed, and it put little pretty icons on your windows, and you could right click and do stuff. I'm going to recommend, specifically if you're new to Git, don't use Tortoise Git. I kind of view it a little bit as a crutch because it kind of keeps you thinking in that same SVN mentality. And in SVN, the process is very linear. Right? Everything happens on one branch. There's not a lot of branching, right? So anybody who uses SVN, do you ever create branches? How often do you actually?
Not really.
My experience with SVN was that branching was pretty rare because it was very painful. With Git, it allows you to branch very easily. And so it enables a whole lot of workflows that you aren't going to discover if you're still using Tortoise Git. So that's my recommendation. The one thing I will say is that the icons are nice. So on many of my computers, I have it installed anyway, just for the nice icons, but I don't really use the right click and do stuff. And also like the way it displays information and stuff, it's not as nice as some of the other ones. So if you're using Tortoise Git, I'm not mad at you or anything, it's fine, but you should try to explore some of the other ones. Particularly Source Tree is just quick and easy because it's free and readily available. It is not the best one though, by the way. It just happens to be ubiquitous. So one of the reasons to learn the command line is for getting help. Because there are 41 different GUIs, if you post a question about how do I do XYZ in Git, you're not going to get somebody posting, oh, in source tree, click here, enter this in this dialog box. You know, you're going to get something like this, which is from Stack Overflow, and there are millions of help questions on Stack Overflow and about Git. And it's all command line stuff. And so you got to either know how to translate that into whatever GUI you're using, or you're just stuck entering it at the command line anyway, in which case you kind of have to learn a little bit about the command line. So it's important to kind of have some idea of what's going on. And really, it's a bad idea in general to just copy commands that you found randomly on the internet and run them on your computer. From a security point of view, and just the fact that you can mess things up if you don't know what they do. If you open up the git bash command prompt, so if you're not familiar, when you install Git for Windows, you get this thing where you can right click and I'll say open up Git Bash, and it just opens a command prompt. It's not the Windows command prompt, it's a special Git Bash command prompt. And you can type in Git help in the name of the command, and it'll pull up a manual page and in a web browser, and it'll give you a bunch of information. The Git help can be sometimes cryptic. It's getting better every release. But it certainly will tell you all the different options, and you can see this is the rebase command, and it's got tons of options there and different ways to use it. So in that rebase command, there was a whole bunch of options there and stuff. And in source tree, if you want to rebase, you right click on the thing you want to rebase and you click rebase, and all it asks you is to confirm, right? So the GUI makes this operation really simple, but the problem is you lose all that flexibility, right? So there's a reason that Git has all those options and stuff. And when you use the GUI, you lose a lot of those options, right? Which means that it's kind of a leaky abstraction. So if you want to do certain things, you have to learn how to use the command line anyway, right? So the GUIs do like the 90% use case, but if you fall in that 10% where you want to do something special, then yeah, that's the problem. So Dan, you got something you want to?
Oh, yeah, Dennis, he wants to, if time permits, he wants to know how do you effectively leverage branches, especially in a team environment, considering LabVIEW's binary nature. Because, I don't know, merging text code is way different than merging, graphical code. And that's always been a problem with LabVIEW, is how to merge this graphical code effectively. I haven't, I'd be interested. It's a very legitimate question.
So if we can hold that thought, I will get to that in a little bit. So when we talk about resolving conflicts, bring that up again and then we'll talk some more.
Okay.
All right. And along those lines of GUIs don't implement all the features, here's a common command that you probably, if you've used Git, Git Commit, which is basically, I want to make a commit. So I want to take a snapshot of my working directory and store it and save it. And you can see it has a ton of options. There's probably 10 or 15 options there. And this is on the right is the dialog box from source tree. I get to enter a comment, and there's 3 or 4 options there and a push button and a checkbox, and that's it, right? So again, you're losing some of that flexibility. It's not the end of the world. If you don't need it, then, and the GUI is simple enough and it works for you, then that's fine too. But it's worth knowing that if you want more flexibility, you can do some of this stuff from the command line. Like there are certain things like that you might want to do. And along those lines too, there's like some things that just aren't implemented. So this is the Git ref log. And basically it's like the ultimate in troubleshooting. So if you did something and you don't remember what you did or you don't know how to get back, the ref log is a log of everything that you've done to your Git repository locally. And it lets you go back in time and undo stuff. But almost none of the GUIs implement this. So you kind of have to know the command line exists to be able to go do that. So I've spent a little bit of time kind of bashing the GUIs, but what are they good for? Well, they're good for some things, right? They're good, as I mentioned earlier, for simplifying commands. So if all those options are overwhelming and the normal default thing works 90% of the time, well, then, and you fall in that 90% use case, then you can just use the GUI and it's simpler. It's useful for displaying a lot of information at once, right? So in this GUI, this is source tree. On the left-hand side, under branches, it would list all the branches that I had. The thing in the center there with the line going up and down is kind of the history. And it shows all the commits. It shows some of the comments. It gives you the date and who wrote them. The bottom right-hand side, on the right-hand side has a diff for a text file that, oh, this is what I changed in that particular text file. And then the stage and the on-stage files. So stage files are files that when I make the next commit, when I make the next version, this is what's going to be included. And on-stage means I've changed it, but I haven't decided to include it in the next version yet. And so I can see all that at a glance. And to see all that information in the CLI would require a couple commands, and you wouldn't necessarily see it all on one screen. So it is really useful for that. Oops, I meant to go back a second. And avoid memorizing commands, right? So on the thing of memorizing commands, if you like using the CLI, one thing to remember is you can just go to the CLI and type in Git, and it will give you this usage thing that gives you the most common commands and kind of helps you with that. So on the CLI, you don't necessarily have to memorize all the commands either. But in the GUI, they're just there, and you just click a button. And so you just have to know what the button is and know where to click, and it does it. And you don't have to type things out. So there is that. One thing, so now I'm going to go into just a couple little hints to make the CLI easier to use. There's a thing called Aliases. And I've got a lot of slides, so I'm not going to delve too deep into all these, but you can set up aliases. So on the left, I had typed in git log, which shows all the history. And then there's some formatting stuff there, one line and graph. So that kind of condenses everything and prints a little graph. And oops. And on the right, I just typed git graph. So git graph is not a native git command. It's an alias that I set up that represents that git log one line dash graph. So I don't have to type it all in. If you want to use the command line effectively, you will figure out that there are certain long things that you type in all the time and that you want to shorten them. The other thing that's gotten really good in the last couple of revisions is Git Status. So there's this Git Status command. It gives you all kinds of information. So it tells you what branch you're on. In this case, it tells me I'm up to date with Origin or Develop. So Origin Develop is the remote server that I might want to sync with. And it's telling me I don't need to do any syncing because everything's up to date. It tells me that I have some changes that are not staged. So these are changes that I made that I haven't added to the next commit. And it gives you some hints about what commands you might want to use for adding those files. So it gives you some hints and tips and tricks. So if you ever don't know what to do, you just type in git status and it'll kind of give you some hints and point you in the right direction. Oh, and the other thing is the command prompt. So the command prompt here gives me a bunch of information. It tells me the blue is like what my username is. Okay, that's not that important. The yellow is my directory. And then in purple, it tells me what branch I'm on. And it tells me how many on-track files and how many modified files I have. So I can just see that at a glance without actually typing out all the git status. If you use git bash, it doesn't look like that. If you go to my blog, I have a thing on how to set that up and make it look like that. And then tab completion. So there's some stuff. This is a short little video, but basically instead of typing out those big long file names, you start typing out the first little bit, and you, after a few characters, if it's unique, you hit tab and it will fill out the whole thing. Because one of the things is that selecting files, especially if you've got deeply nested folders or VIs with really long path names, it's a lot to type out to select an individual file or something. And the tab completion makes that really easy. You can also do the asterisks, so like the shell globs, I think they're called. So if you wanted to add an entire directory of files, you could add the directory name /* and it would add everything. And another one that's sometimes useful is dot. So dot means like your current directory. So you could do get add dot and it would add everything. I don't recommend that. One of the keys to using Git and any source code control is to make really small targeted commits, right? Because if the idea is to be able to unroll and undo changes at some point in the future, if you need to, right? It's easier to undo changes to 1 or 2 files than changes to 100 files and trying to figure out which one you actually wanted to undo and which ones you didn't. And so, and you could also do some basic Linux tricks. So in this case, I used the vertical line, the pipe command. So git graph shows that history, and I piped it to a command called grep, which is like a search function, and I searched for splash. So here I'm finding, I wanted to see where they added the splash screen, and I found, oh, in this particular commit, they added the splash screen, and that's what that's kind of telling me. I see some questions. Dan, is there anything to?
We're just talking about diff. Alyssa made a comment, about the diff and merge tools in LabVIEW and how you can link them in Tortoise Svn. People have just been commenting about their experiences with both those tools. I personally find them kind of overwhelming. So I've explored it. I'm like, that's just me personally. That's my opinion. But it just goes back to the whole, for me, the idea of this graphical language. It's not a text language, and it's a very interesting problem of how to merge a graphical language over a text language. And that's what I struggle with, and I think a lot of, because that's that's the LabVIEW problem, I think. So, but as
Yeah.
you know, up till maybe now, I don't know, maybe Git solves this, but you know, that's what I've seen, you know.
Yep.
So
yeah, so we will definitely talk a little bit about that a little later. The one comment I will make is that the merge tool is more difficult and less useful. The diff tool can be useful. Like oftentimes, like I'll work on something and then I'll get called away. And when I come back, I forget where I was or what I changed. And in that case, the diff tool actually can be quite useful in just seeing, like, pulling up really quickly and seeing like, okay, these are the couple things that I changed. Okay. And it kind of reminds me where I was. Or if somebody asks me to like review some of their changes, that can be useful to just pull it up and see what they changed. It's not as useful as a text diff, but it is somewhat useful. So I've got a lot of slides, so I'm going to try to go a little faster. So the other thing about using the command line is you can do shell scripting. So that might be a little bit out of the scope of this, but basically this is a shell script that I wrote that from the shell, I can create a new GitLab repository, which is like the central hosting thing, and push my changes there and do all that with like one command, as opposed to having to type out all these different Git commands. All right, next up, so this is number 2. The first couple are kind of involved. The last couple will go really quick. So understanding the graph. So one of the keys to understanding and using Git and source code control in general is understanding this graph idea. And this is where Git differs from SVN a bit. So it's kind of important, particularly if you're coming from SVN, to kind of understand what's going on. So here's a basic Git graph that you might see. And you can see the GUIs kind of display this, and there's a way to display it in the CLI. This is where the GUIs shine. They show the graph a lot better than the CLI. But the first thing you kind of want to pick out is the head. So in Git terminology, head is basically whatever you have checked out in your working directory, wherever you currently are and what you're working on. So in this case, head is pointing to main, which is a branch pointer. We'll talk about those in a second. And main points to this commit. So the blue circle is a commit, and that's M. So that's like a state or version of your code, right? And the head reflects what's in your working copy, like at least what you started with, right? You could have changed those files, but that's what you started with. And then the blue circles are commits. And in SVN, right, they're all numbers, they're revisions, and they count sequentially. Git, they're all commit hashes. So it's calculates this hash, and it's some big long chunk of numbers, and it's like and letters, and it's 40 things long. You don't need to remember all those or type those in. You can usually type in the first 4 or 5 characters or 6 characters, and it will recognize it for you, as long as it's unique. But each commit has a reference to the parent commit, so it knows where it came from. It has a snapshot of your code, and it's got some metadata information, author, timestamp, commit message. Important thing to note is you can have multiple commits that have the same exact working copy, the same snapshot, but if they have different history or different metadata, they look completely different. So that's interesting, just side note. And we have these things, so most commits just have one parent. So time kind of flows from left to right, right? So commit A was made first, and then commit B, and then commit C. And eventually the things branched off, and we had 2 people working in parallel. And then M is kind of bringing those 2 branches back together. And so M has 2 parents, right? So both E and G are its parents. So when we talk about merges, that's what we're talking about, right? We've got 2 people working in parallel, and the merge is how do we combine their changes? And when we do that, that commit has 2 parents. Branches are just basically references. I'm going to use the word tags because tags means something else. But they're basically just references. So we tend to think of like Bob as like this branch being like commits F and G in this set of changes, but it's really, as far as Git is concerned, it is just a pointer. And so in SVN, right, you had the .svn folder that held some of your information particular to SVN. In Git, all of your repository information is inside a .git folder. If you want to unversion your code, you just delete that and it throws away everything, and it would be the equivalent like the SVN export or something. But if you go into that .git folder, you can go look around and you can find some interesting stuff. If you go into the res/heads directory, you will find a file for each branch in your repository. And if you open them up, you'll see that it's just an SHA hash. So that's all Git knows. So Git knows the SAM branch points to that particular commit. It's not storing any other information, doesn't know anything else. It just knows that. Which means that we can just move our, well, I'll hit that again in a second. So typically branches, even though they're references and pointers, they move, right? So if I'm on commit D, so my head is pointing at main, which is pointing at commit D, and I make a new commit, I add something, the branch pointer moves to the new commit, right? So as I'm adding stuff, that branch is not like a static pointer. It kind of moves along with me and tracks my progress and where I am. Right? But because it's just a pointer, you can do crazy things and just move it around. There's a command called git reset that lets you just move it. And this is kind of baffling to people sometimes, but it's really useful in the sense that if things get screwed up, you can always just say git reset main and point it towards Y, and it'll just move it to Y and gets perfectly happy with that. It might confuse your coworkers and it might, mess things up in your mental model, but you should just be aware that Git can just move stuff around like that and it doesn't care. And that makes it a lot easier sometimes when you run into problems, because eventually you will run into problems with Git. And then in addition to branches, we have these things called tags, which I think SVN also had tags. I think in SVN and tags, you like created a whole copy of everything. In Git, it really just is a pointer, just like a branch. It just doesn't move. And so tags you often use, like if you release a particular version, you'll tag it. Or in LabVIEW, like, say you're coding in LabVIEW 2018 and all of a sudden you said to upgrade your project to 2019, you might tag like this is the last release in 2018 or something like that. And then we have one other thing, which is remote tracking branches, which you wouldn't have in SVN. And this basically just is the where. So in Git, you have the remote repository, which is the server that you originally started and cloned from, right? It's the GitLab, the GitHub, the Bitbucket, right? Where everybody's collaborating. It's the one that everybody's coordinating all their changes at. And typically it's called origin. It doesn't have to be, but origin/main, that just says on the remote server, there's a main branch and it's pointing to that commit E, right? And so as opposed to our local branch main, which has this merge commit, right? And so we are one branch ahead. So if we were to sync with the repository, that origin main would move to where our main is. And that's all that means. Questions so far? Anything worth discussing?
Not in the chat so far.
Okay, cool. All right, so we're going to do undoing working copy changes. This one's pretty common. If you've been using Git, you probably already figured this out, but we'll talk about it a little bit. So undoing working copy changes means I cloned a repository, right? So somebody had a repository in GitLab or Bitbucket. I got a copy of it, and I made some changes, and I haven't committed them or anything, like taking a snapshot of them, but I want to throw away my changes, right? I changed something. I'm like, yeah, I don't really like that change. How do I do that? Well, there's two ways to do it. If you've been using Git for a while, you've probably learned the reset command, and there's a newer command called the restore command. So the reset command I mentioned earlier is for moving branch pointers around, right? Well, if you type in git reset and you don't give it any parameters, it basically resets it to where you are, right? But that has the side effect that it updates your working copy. So when you git reset and you move the branch pointer around, it updates your working copy to match that. So when you move it to where it is now, it just updates your branch copy, which throws all your changes away. Right? So when you use the git reset command, you're actually like using a side effect. Sorry, Thomas, were you gonna say something?
So similar to SVN's revert?
Yes, so that is one thing with revert. The word revert in Git means something completely different. So just throw that in the back of your head. But so the reset command just throws away everything. It is the blunt hammer, right? It's just like whack, everything goes away. There is a newer command that I like to use, and I recommend. It's called git restore, which lets you move individual files. So you can say, take this file that I changed and throw those changes away. And it also lets you move stuff into like staging areas. So Git has this like 2-process commit thing. You stage the couple things that you want to commit. And then when you make a commit and take a snapshot of a version, it only grabs the things that you told it to grab, which is useful because you can, if you're changing something and you see something over here that needs change, you make all the changes at once in LabVIEW, and then you say, oh, well, these are really 2 separate changes. So let me make one commit with this change and one commit with that change. And you can take multiple snapshots. And the restore command is kind of like the tweezers and lets you do that. Hopefully that was kind of clear. And it's been a while since I've used SVN, but if I remember correctly, SVN, when you make a commit or whatever, or a new revision or whatever, it just grabs everything you've changed, right? It doesn't give you that granular ability to like, right?
You can pick which ones which files actually get committed though.
Okay. Okay, cool. All right. So yeah, so it's similar to that then, that you pick which ones get added. It's kind of the same thing. All right, so the next thing is, okay, I threw away some changes, but what if I want to go back in time, right? What if there's some previous version that I need to access for some reason, maybe to troubleshoot something, right? Somebody's having a problem in the field and I'm on version 3, but they're running version 2 of the code. How do I go back and see that? There's a couple different ways to do it. So the reset command, right? We mentioned that the reset command can just move things around. So I can just take my branch that I'm on right now and I can reset all the way back to B. And that's good, but that's destructive because I'm moving the branch around and I'm throwing away some of those changes. So if you want to throw away changes, right? If I made a couple commits and I made a couple versions, like I don't want those versions anymore, I want to get rid of them, then reset is what you want, right? But often we don't want to do that. We want to, like, we got a version 2.0, we need to do a bug fix on version 2.0. So what we would do is we would use the git switch command, which changes where our head's pointing. So it changes what branch we're on. And you can combine that. If you add a -c for create, it'll create a new branch and you tell it where to create it. And so what this command will do is it says, I was on commit D, somebody else had a problem with commit B. So I'm gonna create a new branch there and I'm gonna check that out. And then any changes that I make are gonna be on this new branch, right? So it would be like, I had version 1.0, somebody found a bug, and now I've got I'm going to create a 1.0 maintenance branch that's going to contain all the things that I fixed on version 1.0, if that kind of makes sense. But there's also a command called checkout. So we're starting to get into the fact that Git is really flexible and lets you do a bunch of different things here. So depending on your use case, you might want to do any one of these. Checkout just says, take my head, which represents what's in my working copy, and point it at B. And when you do that, it'll just update your working copy so it'll look like the snapshot that was at B, right? So this is just like, I just want to go and see what's there. I don't want to actually make any changes there or anything. I'm just curious. I just want to go see. Right? And that's what the checkout command does. And one of the things that's perplexing about Git is if you do that, you're going to end up with this message that says you're in a detached head state and it sounds all scary and all this stuff. You could basically more or less ignore that. All that means is that your head is not pointing to a branch. So if you were to make a commit, you'd make the commit and your head would point to that new commit, but there's no branch pointer there. So if you moved away, you can never get back. And those commits would be lost. So the solution to that is really simple. If you're in a detached head state, you either check out a different branch, or if you want to make changes there, you create a branch there and then make those changes on that branch. And that's basically it. This is just Git trying to be helpful in a weird way. It's trying to tell you if you make commits now, you're going to lose those commits if you move away and you won't be able to find your way back. All right, so now we're on to resolving conflicts, which is kind of part of what we were talking about collaboration and working together.
So real quick, Sam, Dave had a question. Can you explain disconnected head? I think this will occur if you, after a checkout, can you really never get back?
Okay. So if you make, so there's this idea, and if you really want to learn about this, you should look on my blog and check out orphaned commits. But basically what happens is Git does this pruning thing, right? So every time you make a new commit, right, you end up with, sometimes you end up with these extraneous commits that have no references pointing to them. And so Git does this pruning thing where it gets rid of them. So if you were to be on B and you made a new commit E, right, then your head would point to E, right? So imagine there's another circle like above C there that's labeled E and it points to B, right? If you then checked out main or switched back to main, right? And now your head's pointing back to main, there's nothing left pointing at E, right? So there's no way, if you started all the references, all the branches and tags and you trace back through, you'll never hit E. And so Git at some point will just throw that away and say that's not being used anymore. But the problem is if you actually wanted those changes, now they're just thrown away and they're gone. And that's what the detached head is trying to warn you against, if that makes sense.
I guess I didn't know that Git cleaned it up automatically, because that's what I was like looking at. It's like kind of like your checkout. Like, couldn't you just check out back to that hash? But you're saying Git will delete it.
Yes, there is a process and it will eventually delete it. And you have to remember the hash number in order to do that. Which
Right.
will bring up our ref log discussion in a few slides. We'll talk a little bit about how you find that. Right? Because it doesn't have a convenient name and you got to remember these 6 digits in order to get back there.
Yep.
So,
Yeah. So it's Git that cleans it up is what makes it where you can't actually get back.
Yeah. Yeah. And also it's hard to find, but yeah, it's this combination of things. And it'll stick around for like a couple weeks, but then eventually at some point gets like, hey, this thing's been here for a couple weeks. Nobody's used it. Nothing's pointing to it currently. It must be trash. I'm just going to get rid of it.
Okay.
So it's really hard to lose changes in Git once you commit them, but that is one way that they will get lost. So, and there are several other situations that result in orphaned commits. So if you look at my blog, I have an article all about it. I could go into that, but then it would take all of our time. So we're not going to do that. So on to resolving conflicts. So the first thing is the most common cause of conflicts is merging, right? So you're trying to merge 2 branches and both sides have changed the same file. All right, so a little bit about this first. There's an auto merge thing in Git, and it's worth knowing how that kind of works. So like if one side changes a file, specifically with LabVIEW VIs, as long as only one side touches the file, you merge, the merge will have a copy of that file and there's no conflict. There's nothing to resolve. If both sides try to change the same VI, then you end up with a conflict, right? So this speaks to having very modular design. So everything's in a library and everything's separated and every VI has a clear purpose. And that way, if I'm changing something on the database and somebody else is changing something on, I don't know, some file logging, they're not touching each other, right? Because and as long as they're not touching the same VIs, when we go to merge, everybody's happy. That's the basic rule in LabVIEW. The other thing is to separate compiled code, which I wasn't going to cover, but there's an option in LabVIEW to separate compiled code. If you don't do that, you will end up with lots of conflicts. So you can Google that and you'll find a lot more information about that. It's pretty much always a good idea to turn that on. There are a few edge cases where you don't necessarily want that on, but they're very rare. So where was I? Avoiding conflicts. Yeah, so that's the key to avoiding these conflicts. We'll talk in a second about how to resolve them if you get them. So I tried to merge this other branch. It gave me a problem. Right? It says right when I merge, it gives me the thing. And then you'll notice that the branch, instead of saying on main, it says main and a bar and then says merging, right? So that's Git's way of saying, hey, you're not done yet. If you run Git Status, it will tell you what the problem is. The GUIs do a good job of displaying what the problem is. They all kind of do it a little differently. But basically here it's saying the problem is this README file, right? So resolving text conflicts, we'll go through that really quickly because sometimes in LabVIEW you will run into this because, right, we have config files and things that we use. And if 2 people edit the config file, you could end up with a conflict. Basically, you go through the text file and you open it up and you look for these arrows and one will say head and one will say the name of the other branch. And so the side on head, this is what I added. So after contributors, I added a line that said me. And on the other branch, somebody added a line that said Sam Taggart. And so basically this is Git's way of flagging. This is where the change is. And basically all you have to do at this point, if you're trying to resolve the conflict, is figure out what that line should look like, right? So you delete all the markers, all the greater than, less than, and the equal signs, and you edit it to say whatever you want to say. So you could pick me, you could pick Sam Taggart, you could pick some other thing. You don't have to pick either one. You can pick some random thing. And you set up the text file just the way you want it and you save it. And then you have to tell Git that you've resolved things. So you do git add, you add that file and that says Git in this merge commit, this is what I want the file to look like. And when you're done with that, then you just do Git commit and it'll finish the commit and everything's happy and it's set to whatever you set it to. And so the merge, that merge commit and the contents of that README file will look like whatever you left it as when you added it. And that's how you resolve text conflicts. One thing I will say is if you have one of these, you want to search through your text file and make sure you get them all, because there can be multiple conflicts. So if there are multiple conflicts and you leave them in there, then when you go to run your program, it's going to complain, right? Because it's not going to know how to interpret the crazy greater than, less than signs. And that's text files, and it's pretty easy. For VIs, the process is actually similar in the sense that you'll get a message that you got a conflict, and it'll mark it and it'll say, this is the file that has the problem. Now you can't just open the VI in a text editor and you won't see all those tool markers and stuff, right? Git knows it's a binary blob. It just says, I don't know what to do with it. But if you have the LV merge and LV compare set up correctly to integrate with your, either the command line or your Tortoise get or whatever you're using, or source tree, you can open it up in LV merge. And so on the left, we have, hours, hours, base, and yours. So basically the hours are, what do they call it? They call it theirs, yours, and base. Okay. So theirs and yours are the two branches. So right, the file was in a certain state and then two different people made changes to it. Right. So the state that it was in before anybody made any changes is the base. That's the one in the middle. And then theirs is the changes the other guy made, and yours is the changes you made. And in the dialog box on the right, you can go through each set of those changes. You can choose theirs or yours. So you say, do I want to, or neither, right? So you can say, hey, throw away both sets of changes, or keep my changes or keep their changes. And then at the top, it will show you what the VI looks like, and you can do some basic editing there. It's not a full-fledged editor, so you can't do everything you'd like to do, but that's basically how that works. And then when you got it the way you think you want it, you click close, you got to tell it to save, and it'll save everything. And then you'll have the VI in its new state on disk, right? Just like the text file after you resolved all the conflicts, it's in its new state, and then you can just commit that. And if you want, you can open that VI up in the editor and you can do some more editing outside of the LV merge tool. And if the LV merge tool won't let you do everything that you want to do, you can go open that up in LabVIEW and do that. So that's the basics of how the LV merge works. It works really well for simple VIs, right? This one's pretty simple. There's not a lot of changes. There is a flag to it when you set it up that removes any cosmetic stuff, because cosmetic stuff will cause you no end of headaches, because somebody will move something by 1 pixel and it'll detect it as a change. And you're like, yeah, I don't really care. Particularly on the block diagram, like you really don't care. On the front panel, you might, but block diagram, it's like, oh, they moved the constant to 2 pixels. Yeah, big deal. My advice is don't be afraid of using LV merge if you end up in a situation where you need to, like you can and it works. But if you're using it a lot, that's a sign that you need to communicate better with the other people on your team, and you need to assign work a little bit better and not be stepping on each other's toes and make your stuff more modular, because this is a pain. And if you're trying to do LV merge on big, huge VIs that have like hundreds of like your main UI that's got a huge, event structure with 20 events, you're going to hate life. And you're going to quickly realize that that is not the way to go. But for a small, simple VI where somebody changed 1 or 2 little things, you changed a constant, this works perfectly fine. Does that kind of make sense and answer some people's questions? And the Git diff tool is actually quite useful. And it just basically, instead of 4 windows, you have 2 windows side by side, and it lists all the changes, and you can click on them and it'll highlight them for you. It's not perfect, but it's pretty good. You definitely want to do the filtering with the cosmetic stuff. If you look at my blog, I have an article on how to set that up. And if you set it up right on the command line, you can set it up so it will work in the command line and in any of the GUIs. The problem is each of the GUIs requires a different format, and it's a huge pain in the butt. And you can get it to work with Tortoise Git, and then you try to use it in source tree and it doesn't want to work. And so I have a method that works that I have found works everywhere. So I recommend that. Yeah, so if you have lots of merge conflicts, You want fewer, smaller VIs. Avoid, as Fabiola calls, the VI that does everything, because that's obviously going to be a huge headache if you have multiple people working on that. Because they are going to step on each other's toes, and the VI is going to be huge, and it's going to have tons of stuff to sort through. And modularizing your design. So if you don't use classes and libraries, highly recommend it. Highly recommend you look into something like DQMH or Active Framework or something to really go the next step too. And then just communicating better. Do we have any questions, Dan?
There's a question, I believe it is, so is there any way to get it to stop thinking if the visible case has changed, if the VI has changed? I don't understand the question myself.
Oh, I think I understand it. So if in Git, so if in LabVIEW, right, you're in LabVIEW, you open up a VI, you don't edit anything, but you go to the block diagram and you change which case is visible, right? When you exit LabVIEW, it's going to ask you to save that. If you save that, now Git's going to think that it has changed, right? Because the file on disk has changed. And that is a problem. So number one thing to do with that is avoid hitting save all. That is number one. If you hit save all in LabVIEW, you're going to have 50 million changes. The separate source code control will also fix some of those problems, because you'll do stuff that affects the compiled code but doesn't affect the diagram, and so that will avoid that. Yeah, and the other thing is too, if you like, I get in the habit of doing very small targeted commits. So I'll go into the code base and I know I'm going to change this one VI, and I know that's all I'm going to change, and I'll change it. And maybe in the process, I'll open up some other VIs. And even if I accidentally hit save all, when I go to that Git Status screen, it'll show me like 50 changed files, and I know I only changed one of them. I will often just throw everything else away and just save that one change. And the reason to do that is because later, if you're going to try to look through to debug things, it'll be much easier to see that that's the only file that changed and all the other stuff was just cosmetic, because it just won't be there. If you have something that has 50 files in it in one commit, chances are you changed one or two files and the rest were all cosmetic. But trying to figure that out after the fact is really hard. Does that hopefully answers that question? So yeah, the small targeted commits. I didn't include that as one of my 10 tips, because that's kind of like universal as far as if you're using SVN or Git, like that's something that you should try to do anyway. So what you really don't do is like make 50 changes and then at the end of the day, just do save all and commit everything. It's certainly better than nothing. And you should, if you're contemplating, should I add it to source code control or not? In that case, yeah, add it. But like throughout the day, you should be committing multiple times. Like I commit probably every 10, 15 minutes sometimes.
Yeah, I do. It depends on the design cycle I'm in. In the beginning, I don't commit. Maybe I'll commit once a day because everything's kind of prototype and loosey-goosey. As the project moves along, my commits ramp up, and toward the end, every little change I make, I commit. And I found that that's really helpful, because if you're trying to commit, from my workflow, this is just me personally, you know, I'm in this prototyping, just messing around phase, and you know, source code control is useful, but it's, you know, but as I get in the middle and toward the end of the project, boy, you know, it really shines, and especially, you know, I like that really granular commit, and that's just what I found to be helpful, you know, because like, you don't really need like this granular thing in the beginning because you don't know what you're really wanting to do or what you're doing, you know, but at the end, I definitely need all that. So that's just my comment, I guess.
So I will comment on that. Two things. One, I also at the very beginning tend to have larger commits. Like I still commit fairly often, but I have the larger, because like if I add a new DQMH module or an actor to my project, that's adding a lot of VIs. Or if I add a new class and it's got 4 or 5 VIs, that's a lot to add at one time. So, and to get it to a point where it's like somewhat useful and worth saving, right? But the other thing I will add, Dan, and this applies to you and other people, like, I think that part of that, like, you know, you're like, oh, I'm just prototyping, so I'm not going to check SVN. I think part of that comes from the SVN mentality, where creating branches is very hard. In Git, it's very easy to create branches. So it's easy to create a branch for that prototype feature. And then at the end, if you don't like it, you just throw the whole branch away and delete the branch and you're done.
Yeah, but I can still, I don't know. But you know, I can still go back in SVN. So I you know.
But I guess the thing is, if you have the prototype idea and then you decide, oh, I don't like it, but then a few weeks later, you're like, wait, didn't I prototype something like that before? Now you can get it back, I guess, is kind of where.
Yeah, I mean, and technically you could, I mean, maybe it's easier in Git. I haven't honestly played around with Git, and I haven't used the branches. You know, I've not utilized that feature. And I haven't been, like, it hasn't been a problem. I guess that's what I want to say.
Yeah.
You know what I mean? I have used SVN, the feature Tortoise Svn, to go back in time because something got screwed up, or I want to go back in time, or I'll just pull out a certain VI and be like, oh yeah, that's what happened. You know what I mean? And then it's just wonderful, you know? So, you know, the branching is interesting to me. I remember learning about it when I first learned SVN, but I haven't, maybe I need to learn more about it or whatever, but I haven't, you know, seen the need for it yet, you know, but maybe that's just a learning thing for me. I don't know.
Well, also, we will talk about this in a little bit. Because branching is so easy in Git, you can get yourself into trouble and have a huge spider web of branches, and it's a big mess. So there is a downside to it as well. So we'll cover that in a second. One thing I will say is, in Git, anytime you do anything that could generate a conflict, like a merge or a few of the other commands that we'll talk about, like rebase, you still want to run some tests after you do that, because you can have stuff that will merge correctly and yet still break your code. An example is, if on one side I've got a sub VI and I decide, yeah, I'm not going to use that anymore, and I delete it, and the other side doesn't touch that file, right? So Git just says, hey, this side deleted that file. Git says, all right, fine, from our merge commit, we'll delete that file. But this side might create a VI that calls that VI that you just deleted now. And now when you merge your code together, you've got a code that calls a VI that's no longer there, right? And that's just one example of how, even though the auto merge says, Git says, yes, this is fine, it's still broken your code, right? So don't just assume because you merged and nobody says there's any problems, that there's not problems. You should be cautious and run your tests again. Gracefully undoing changes, right? So say we made a commit, we made some change. Maybe somebody made a commit that introduced a bug or something and we want to undo it. How do we do that? So one way is to rewrite history. We can just take the history, like in SVN, I feel like your history is more like fixed, right? It's hard to go back in time and undo things and change things. But in Git, we have some commands that let us do that. So we have the reset command that lets us just move the whole branch pointer back. And so we can throw away the last 3 or 4 commits or however many commits. And it's very easy. We can also do something called Rebase Interactive, which is designed specifically for editing history. And it lets you go back 4 or 5 commits. And you know, you might think that's not that useful. It is useful in certain situations. So it's useful in commit messages. So maybe like you have a standard where you're supposed to put like a JIRA tag or something in your commit message and you missed it. Well, you can go back in time and add that. And you can say, you can add some notes and stuff like that. You can also take 2 related commits and squash them into one. So where that happens in LabVIEW a lot, maybe you guys have done this too. Like I'll have a library and I'll add a file and I'll save the file, but I forget to save the library, and I'll commit the file and not commit the library. And so then that commit, like if somebody checks it out, it's going to be broken, right? So I can then go back and either use the next one, git commit amend and add that, or I can do this Rebase Interactive and stop on that commit and say, yeah, this commit should include that updated library file, so that then it actually makes sense if somebody were to check it out. So the whole idea of rewriting history, like some people like it because it tailors the history of your project and makes it more meaningful. And some people hate it because they're like, I want it to record exactly what I did and that's it. And if I screwed up, then I want it recorded and I don't want to change it. So it's kind of a personal philosophical thing. But rewriting history, you should be very, very careful. In Git, right, we have this distributed model, we have the central server, we have our own local copy. Changing things locally is fine. So if you have something that's only local and not on the remote server and hasn't been pushed up there and you change the history, that's fine. That's totally valid. You should do it. The problem is if you've already pushed that to the server and you rewrite it, then when you go to sync with the server, it's going to cause all kinds of problems. It's going to cause problems for everybody else, right? So that's why, like, in Git, a lot of people are like, oh, don't rewrite history, don't rewrite history. It's okay to rewrite the history as long as it's only local. But if you break that, you will cause yourself no end of problems. So like the conservative approach is don't rewrite history. So just FYI. There is a command that lets you undo things without rewriting history. So in this case, if I wanted to get rid of commit B, I could do the git Rebase Interactive and I could just remove B and that would be fine. And I could just have it, go ACD. But if I've already pushed that to my repository, it's going to cause problems there. So what I'm going to do is there's a command called revert. And basically what it does is it looks at the commit B and it says, well, what changes we're introducing there? What changed from A to B? And it generates the inverse of that. So if B added a file, then the inverse would be to delete that file, right? So then it generates this B not, and it creates this commit called B not that does the opposite. And so that works. And in this case, you're adding a commit. So you're not rewriting history, you're adding to history. So that's okay, right? And when we go to sync, it'll just add a new commit that's B not to your remote repository and everything's good. The one downside to doing that in LabVIEW is because they're binary files, how do you generate the inverse of a binary, right? So it's going to generate a merge conflict and you're going to have to resolve that and everything. So, 601 half dozen of another. An easier thing to do might be to just go and look at what changed in B and then just create a new commit that does the exact opposite, right? And not use the built-in git revert command. So it works well for text files. I know that. For LabVIEW files, but the idea is don't go back and change the history that's already published, add onto it to undo whatever you want to undo. And then we'll talk about the rebase command. A lot of people avoid the rebase command because they get that message very early on that like, hey, rebase rewrites history and you don't want to rewrite history and that's bad. But rebase is actually quite a useful command. So we'll talk a little bit about what it does. We're getting close to wrapping up, which is good because I was worried about time. Let's talk about combining changes, right? So we had this initial commit A, and Alice and Bob are both working on the project, and Bob created his own branch, and he's made 2 commits on his branch, and Alice has made 2 commits on her branch, right? So they're working in parallel. Well, one way to combine those changes is to create a merge commit. So if Alice wants Bob's changes, she can merge Bob's changes into her branch, right? And create a merge commit. We've got this commit that's got the 2 parents and she'll resolve any conflicts if they're there. And now you've got this commit that combines both sets of changes. And you can see the history shows that. Right? Now, the problem is if you have a lot of branches and everybody's merging in everybody else's branches, you can get a really spiderweb project pretty quickly. We'll talk in a minute about how to do that. But there's a command called rebase. And what this does is Alice wants to incorporate Bob's changes, but she wants the history to be nice and linear. So what she does is she takes her changes, commits D and E, the ones that she changed, right? So you find the common one between her and Bob. So they're both at A and everything's the same there. So she takes her changes and instead of having them be made to A, she makes it as if she made those changes to Y, which is where Bob is. So she looks at the changes between D and A, and it creates a new commit, D prime, that just takes those changes and applies them to Y. And then she applies those changes again. And so what you end up with is on the right, you got this nice linear history. And on the left, you've got the merged history that has this like branch there. And so it's 6 of one, half dozen of the other. In the grand scheme of things, maybe you want to see that Bob and Alice actually worked in parallel at that point. Or maybe you just care about like my latest and greatest version of my code is like a linear thing. And so, yeah, Bob made his changes and then Alice made her changes. And I don't care that they were made in parallel. And I don't care about losing that history. Does everybody kind of see that? I mean, in both cases, if you start at Alice, right, and you go backwards and trace through all the parents to get to A, you go through Bob. So you have all of Bob's changes either way. It's just a matter of what the history looks like. does that like blow people's mind, or is that like?
I could see that causing issues though, because if the code interfered, now your D prime doesn't work when you rebase. Your D would work on a separate branch, but if Bob's code interfered with Allison, is your D prime now, that commit doesn't work, may have issues.
Yes, so that gets us to the next slide. So you can have conflicts. So if you were gonna have, but the part of the thing is, if that was gonna interfere, you would have conflicts either way. So if you merge or rebase, you're going to end up with conflicts if you both touch the same files.
Not even that. Like, use your example, thinking about where you delete a VI and someone's using it. And I understand that at M, and let's say M is missing from the linear, the rebase, but both of them could work at M in both of those cases. But on your branch approach, commit D could work and commit X could work. But on your rebase, D prime could not work if Bob's changes caused interference.
Yes. Okay. So I get, so if somebody were to check out D prime by itself and run the code, it might not work.
Right.
That is
right.
very much true. Yes. Yeah. So that is a valid concern. So you're creating commits that never actually existed in somebody's repository on their machine at any particular time, right? Because this D prime is not D, it is the changes from D applied to Y, right? Which might have a conflict. So that is true. So it does affect the ability to go back through each linear commit in your thing and check each one out and run it. That is true. So that's, and part of that is like changing the way you think a little bit from SVN versus Git. So in SVN, right, because every time you made a change, you pushed that change to the server, you didn't want to break things, right? It was really bad to break things. In Git, it's more like you can have those intermediate commits that are broken. The end commit where you end up, you don't want to be broken, if that makes sense. You can have those intermediate steps because when you push it, you're pushing the entire chunk. And so the main is going to jump to whatever that last commit was. And so the main will not be broken. The main will not stop on those intermediate commits. It goes right to the end commit, if that makes any sense. So if somebody were to check out main, they're not checking out that broken commit. They're checking out the end commit, right? Because the problem with SVN is if you introduce a broken commit and somebody else decides to check that out to go make their changes, they've checked out a broken commit. And if two people do that, they've both got a broken commit. They're both going to fix it in two different ways. And then you create this big conflict when they come back together, right? That's the main problem there, right? In Git, you can push something where there's 3 or 4 broken commits and a good commit. And if somebody checks that out after that, they're going to check out the good commit to make their changes. So it's not as big of a deal. If that, am I making sense? Am I losing people?
I understand what you're saying because I've worked with the predecessor to Git, Mercurial. So it's the same concept. Yeah, and the only thing I'd say there is if you have, you're going to fix the issue on your local system, then what's the point of that history? Because it's broken. So, hey, like you said, it's personal choice.
Yeah. So it is broken, but the one nice thing is though, even though it's broken, you can still do a diff between D and Y and see what changes were introduced there, right? So you still have that broken thing, but you can see at least what they were trying to do, and you still got the commit message. So, yeah.
So there's a question, Sam. I'll just, if you could just read the chat. I think it's from Greg.
So before I get to that, just one more point, and that is that in SVN, history is kind of this like defined thing, and you can't go back and edit. And Git, history is fungible, which is really a crazy, interesting concept. So, all right. Regarding the prior slide on reverted commit, does a reverted commit B prime remember what earlier commit it reverted from, including its branches connections as they were configured at that time? No, it is a completely new commit. The only thing that links it is Git in the commit message will automatically add reverted commit, and it will tell you which commit it reverted, but it doesn't know. You can there's probably a way to determine that, and Git might try to determine that. It might say, oh, well, this commit is this set of changes. What's the inverse of this set of changes? Oh, it's that commit. It might be smart enough to do that, but I don't think it is. I think once you do that, it just completely loses any connection.
Okay.
Does that make
Thanks,
sense? Sam. Yeah. Yeah. And so when I said that Git was complicated at the beginning, these are some of the complications, right? It allows you this great flexibility, but then you run into all these weird corner cases and edge cases and things. And so it gets complicated. I wish I could say that it was like simple and easy. And so those of you who are using SVN, you might be sitting there saying, yeah, it gets so damn complicated, I'm never going to try it. And that's a valid point. I'm not going to argue with you. I will say that you're missing out on some of the benefits of Git, but you aren't dealing with all the complexity. So maybe that's trade-off is worth it for you. All right, so comparison quick between merge and rebase. Merge is additive, right? You're adding a new commit. You're not changing anything existing. Rebase, you're writing existing commits. Merges can create convoluted history, and we'll see an example in a minute where that can really come to bite you. Rebase creates a nice linear history, right? So you end up with a very linear history like you ended up in SVN. And SVN, pretty much most of your history, I'm guessing for most of you, was very linear, right? Because branches were just kind of a pain and people didn't typically do them. Merge preserves the branching. It shows that those two changes happened in parallel. Rebase, because it flattens it, it hides it. Merges are very easy to undo because it's very obvious where the branch happened and things came back together. Rebase, right? If you weren't familiar with it and you just see a big long chain of commits, well, who rebased what where? Right? You can't easily figure it out. We'll talk in a minute about a way to undo rebases, but it's complicated. Other thing, we talked about conflicts. So if you merge a rebase and you have conflicts, you're going to have conflicts whether you do one or the other, right? So if these changes stomped on each other's toes, it's going to happen. The problem is with a merge commit, you just resolve them once, right? So you make the merge and it creates commit M and all the conflicts show up at once and it says, hey, fix all these conflicts. In the rebase scenario, as it applies D prime, you could run into a conflict and Git will stop and make you resolve that conflict. And then when you apply E prime, you could have another conflict and it'll stop and make you commit that conflict. So the total number of conflicts is the same in either case. It's just how many times Git stops and prompts you and makes you go and resolve them. If that makes any sense. And then I mentioned the interactive rebase. So you do interactive rebase and you say, I want to interactive rebase the last 5 commits, and it gives you a list of all the commits. And you can reorder them, you can delete some of them, you can combine some of them, you can tell it to go back and edit some of them. You can tell it you want to edit the commit messages for all of them. And so it's a really useful thing. Again, the big thing with the rebase is just don't do it on stuff that you've already pushed the changes. If it's going to rewrite something that you've already pushed, that's bad. So it's worth looking through the graph and seeing before you rebase, look at the graph and see where the origin is at, see what you've already pushed and make sure that when you rebase, you're not going to rewrite any of those commits. And as long as you're not rewriting those commits, it's fine and perfectly valid. All right, we got a couple more and we got some time. Let me look at the chat. How do you set up Git for merging a LabVIEW VI? Yes, I think I mentioned there's a bunch of tutorials out there on how to do it for the various different tools. If you go to my blog, sasworkshops.com/blog, and search for LV Compare, it'll show you how to do that. I have a way of setting it up that will work for just about any tool that you want to use. It's a multi-step process, so I can't really get into it right now, but it'll tell you how to do it and it should work. And if you can't figure it out, you can always send me an email and I'll be glad to help you troubleshoot that at some point. So built-in history. So this Git ref log kind of tells you all the different things that it's doing as you move around. You'll notice on the left, the yellow is the tag. That's like the hash or revision. It's an abbreviated version of it. And then in parentheses, it tells you what branch was pointing there at that particular time. And then you'll see it says head, at, and then brackets and 0 or 1. You can use those as shortcuts. So you could say, you know, I want to check out head at 4, and it'll take you back to where you were 4 things ago. Right? And so that helps you to undo things. If you do a rebase, it will show up in here. Each one of those commits will show up in here. It'll say, hey, you were here, then we moved here, then we applied each of these patches to get to where we are. And so you can undo all that if you want. And there's an interesting way to do that graphically. So if you type in git log -- ref log, in this case, git graph is like my version where it has all those extra parameters, but it will show you something like this. And so you can see there's a whole bunch of commits there that have nothing pointing to them, no branch pointers or anything. Eventually those will disappear from Git. So if you wanted to rescue them, you could use this git graph ref log and you could see all the ones that nothing's pointing to, and you could go in and add a tag or a branch there to point to them, and then it will preserve them. If you've got something that's like this branch that's way off to the side and nothing's pointing to it, and you don't want Git to get rid of it, you can just tag the last one on there, and then they'll all be preserved. So that's just a useful thing. All right, Git Flow Tools. All right, so this has to do with branching and creating a mess. And you can look at this, and at first glance, if you're not used to looking at one of these graphs and you've never seen one before, it probably looks like chaos. There are a whole bunch of branches going on there and merging. And so Git Flow is a way that has a very defined way of how we make the branches and how we merge them back in to kind of prevent chaos. And you've got like, the basic way is you've got two long-lived branches. You've got develop and main, and develop is your latest and greatest features. And then main is what you've released to your customer. And all the other stuff are just where like most of the work goes, and the changes go into the feature branches. And when you're ready to release, you do your last minute release fixes in your release branch, and then you merge it into the main branch. And so the features and the rebase release and the hotfix are short-lived branches. You use them and then you throw them away. And the develop and main are basically just collection points to collect all the commits. That's the basics of it. There's a whole lot more to it. And there's a bunch of rules and conventions for how you use all these branches. If you don't have, so if you're using Git and you are making branches, you want to have some kind of strategy or thought process behind it. Particularly if you're like, if you make a local branch, okay, who cares? But if you're going to push them to the server and you want people to collaborate on them, you've really got to have some sort of strategy. And there's a whole bunch out there. There's several other ones. Git Flow is just the most well-known one. And I picked that because I wanted to make you know that there are tools for using Git Flow that make it way easier. So there's a command line tool, and there's a tool in source tree and all the GUIs that helps you do it. And so basically in the command line, you type git flow feature start and you give it a name, and it'll create a feature branch with that specific name. You make your changes. When you're done, you say git flow feature end, and it will merge it back in where it needs to go. And it takes care of all that for you. You don't have to remember where to start it from or where to branch it off of and merge it back into. It just does it. And the source tree GUI has the same thing. You click a button and it says, do you want to start a new feature? You click yes, you give it a name. It creates the branch for you. When you're done, you click finish feature, and it will merge everything back in for you. And then your Git repository will look like this, which depending on your point of view looks very well organized or looks like chaos. There is a lot going on, but it is actually organized, believe it or not. And then the last tip that I have is a website called Oh Shit Git. If you haven't heard of this, it's really good. It's easy to remember. There is a PG version called Dang It Git. And basically, if you go to that website, it lists a bunch of things. It's got like 10 scenarios. It's like, here's what I did. Here's what I meant to do. How do I fix it? And it gives you a handful of commands to go do that. And again, I don't recommend just typing random commands off the internet. You might want to do a little research and see what they do first, but it will get you back from some problems. So like one of the problems is, oh, I was on this branch and I made a change, but I wanted to make the change to that branch. How do I fix that? And it tells you how to do that. Or, oh, I made my commit message, but I forgot that I wanted to add a tag for this Jira issue. How do I fix that? So it's very much problem and solution oriented. And I highly recommend it. There's a lady who wrote that. Her name's Julia Evans. She's pretty cool. She has a thing called Wizard Zines or something. She makes like little magazines that have like tips and tricks in them. It's pretty good. Lastly, using Git is more than just the tool, right? So it requires some coordination and teamwork and communication. If you've got a lot of people working in parallel, you need to make sure that they're not all stepping on each other's toes. And if you want to learn how to use Git, my recommendation is just create a new folder and create a new Git repository in there and add a bunch of text files and play around and see what happens. Almost all the commands and stuff are very easy to see what happens when you're looking at text files. It makes it very easy. And then as you get more ambitious, you can add a few simple LabVIEW files and see what happens there when you try to add or when you try to merge and rebase and all that, and you'll see what happens and see what the results are. I mean, you can read books and do stuff, but unless you practice, you're not going to learn it or remember it. I have a blog. I think I mentioned a few times. There's a whole section on software engineering and source code control, and it talks all about it. And a lot of the stuff that I talked about, there's some articles on there that are quite useful. And we have a course. So there's about 6 hours worth of video there, broken down to like 10 or 15-minute chunks. So you can watch one on your lunch break for a couple of weeks and get through it. It's very useful.
Real quick, Sam, there's a question from Alyssa that says, is this Git flow strategy described in a blog or an article somewhere?
Yes, if you Google Git flow, so I have an article about it on my blog. I can try and find it. There is the original article too. Let me see. I can throw a link in the chat. Any other questions?
I have a question. If you're interested in Git and you're using Tortoise Svn, how do you migrate repository? How do you migrate to Git?
All right, so there's a couple ways to do this, and that's a very good question. So the naive way that probably works is check out all your code, export all your code from SVN, create a new GitHub repository, and just push it. That will move you over to Git. The downside to that is you lose all your history. Right? So if you want to preserve your history, you need to, there are tools to do that. You need to Google a little bit. There's some scripts that will do that for you. And it will, you can migrate and keep all your history. That is possible. It does require a little scripting. There may be something that works like out of the box. You run one command line and it does it, but most of them are like bash scripts and you got to edit a few things and move some stuff around. The one thing that's a problem when doing that is the way that Git and SVN handle users. So SVN, I think, handled users based on like your Linux permissions, and you had to have special, like, however it did it. And Git does it based on emails. So you have to provide like a translation table that says this Git or this SVN user corresponds to this email and name, and it will do that for you. So
okay.
Why do I say branching is difficult in SVN? Well, A, I remember it being time consuming, and B, it actually creates like a whole separate folder versus in Git, like I type in Git branch and it's instant because all it's doing is just creating a new text file with a hash in it.
The memory usage you're completely correct on. Like that is a big thing where Get and Mercurial were pointer based, where SVN is more copy based. Yeah. But I guess what my experience is, because I use both of these based on customer, so I guess I'm kind of familiar with both, is usually the complaint that I see, or at least my complaint is that the merge in SVN, it doesn't show any relationships. There is no showing that something merged. And apparently that is a philosophical reason. There's a whole reason why that is that way in SVN. But other than that, I don't, besides like you're saying about, yeah, I guess you say memory or file sizes, I don't know difficulties of branching in SVN. So that's why I was curious.
Well, I don't find very many people who branch in SVN, to be honest with you. But a separate point to you, you might look into a tool. There's a tool called Git-SVN. It's a command line tool. It basically lets you interface a Git repository to an SVN repository.
Yeah,
So
I think I've seen that.
Yeah, you do all your changes and you use Git like you're using Git. And then when you go to sync to the SVN repository, it basically takes all your history, makes it linear, and puts it up as an SVN revision. So that's a very useful. Anybody else who's thinking about switching over, that is kind of useful. It might be more hassle than it's worth, but it's worth thinking about. Because as a contractor, I have not encountered anybody who uses SVN recently, but like if I did, that's what I would use, because I'll just use Git and I'll do my normal workflow, and then it'll interface with their SVN repository and make it all work magically. So yeah, there is that. Fabiola has a bunch of information. Yes, Fabiola has some very interesting stuff. So Fabiola is very big into using source code control as well and promoting it. So, the SVN thing. So I'm going to go look at the Git flow thing. If anybody else has any other questions, I'll see if I can find a link. I think my article actually links to the original one. So I think I can just get away with one. Here's an article on Git Flow. Let me throw it in there. This is using Git Flow in source tree. So I show you how to use the source tree tools for Git Flow, which is the easy way to do it. And I think I referenced the original article in there too. I think I can get to that. The picture that I showed you is actually a simplified model of the original one. The original one actually goes into way more detail. But basically, it's really good for a system where you're doing releases where like say LabVIEW, like they release every year at a specific time. So they build up all this backlog of features. And so that's the develop branch builds up all those backlog of the features. And then when it's release time, you create a release and you drop it off into the main branch. And it kind of lets you separate those two things as opposed to like, hey, every time I have a new feature, I create a new release. Like, for example, like websites and stuff. If you're running a website, you add a new feature, you don't want to wait till 6 months to actually put that feature out. You just merge it right in and make a release right then. So, all right, a question. Do people find that interesting, or is that like over people's head? Because I was kind of worried about like the level and like people not being super familiar with Git. Like, were people able to at least follow along and get something out of it? I hope.
Yeah, I got a little bit out of it. Yeah, me personally, I'm not familiar with Git at all. I'm kind of in the lagging camp of, I really like the simplicity of SVN, and I'm starting to see some of the features with Git, and that's kind of what I wanted to learn about. Is like, okay, what are these features, and how can I use them, and is that of value to me, personally,
Yeah.
and I'm still learning, so and I am disappointed though that Git does not have a better GUI. I'm surprised by that. So,
well, you might play there are 41 different choices out there, so one of them might suit your
needs.
Yeah,
maybe you're right, and I'm not a heavy user, so maybe like. And I'm not a heavy user of SC. By heavy user, I mean I don't use it. I don't exercise it hardly at all. I'm a very basic user. Maybe you're right. Maybe I should just get Tortoise Git, and since I don't need, maybe that would suit me personally.
So if you're using SVN now and you want to switch, Tortoise Git is a good crutch. I mean, I don't like, my issue with the Tortoise Git thing is just that I feel like in order to use Git and be good at it and actually know what you're doing, you have to understand the underlying model a little bit. And the Tortoise Git completely hides that from you. That's kind of the way, but like if you're used to the Tortoise SVN, it's almost identical. Like you could use it and almost forget that you're using Git and just.
Yeah, that really appeals to me.
Yeah. And I mean, there's a certain, and that might be a way to get your toes wet, I guess.
Yeah.
I know. I see David making faces, so.
Well, coming from Mercurial, because that's actually the first one I used, Tortoise HG and Tortoise Get are nothing like each other. And so that's actually, listening from Fabiola, a lot of people, if you came from Tortoise HG, you are not using Tortoise Get. And I guess from what she's put out, and I heard this a lot in the Architect Summit, a lot of people in the LabVIEW community appear to be using Fork as their interface. But yeah, from what I've seen, I mean, from an SVN relationship, maybe you're right that Tortoise Get would be a similar thing. But from a HG or mercurial relationship, Tortoise Get is not the place to be.
Yeah. So it sounds like there's many different use cases for this technology, and you just have to figure out where you fall in that and select the appropriate tool. You know, for example, I'm a single developer and I'm not working on a team. So my needs are different than if you're, working on the LabVIEW source code. Like, I like that example that Sam gave. That's a completely different use case, and you need completely different tools. But the tool that might be overkill for me. Maybe, I don't know. But I think maybe that's why there's 41 different GUIs, because there's 41 different use cases and how people think. So
my one piece of advice is, if you're going to use Git in a team, you need to sit down and talk about and have a plan for how you're going to handle branching and merging, and like what strategy you're going to use, because there are a lot of different strategies, and if you're not all on the same page, it can get very confusing very quickly.
And that's true with SVN as well. I mean, you have to sit down and they have a copy merge method and they have a lock method, and you have to get everyone on the same page which method you're going to use. And then once you decide on a method, you have to develop your own workflow as a team to manage that. And if you don't do that, you're going to get in serious trouble. I could definitely see that.
Yeah, and I mean, even without the whole branching merging method, you still need the model, the communication around who's working on what.
Absolutely.
You can't just say all of you go and you all go make changes and just, this is what we got to go do it, because they're going to step all over each other's toes.
Yeah, because I think that the message I'm taking away, and I've taken away all these years too, it's like, the tool is not going to magically manage this for you. You have to manage it. You have to set up your directories, and you have to understand what's going on in your team. You have to have buy-in from your team as well, and if you don't, you're going to have a lot of problems, so I don't know, that's just kind of going back to just source code control, basics, just deciding on a model, deciding what tool to use, and deciding what workflow that you're going to adopt, and sticking to it,
Mm-hmm. Yeah. And I mean, my opinion on a lot of this has changed over the years, but like also I'm a big fan of like adopting the simplest thing that could work and then only adding the complexity when you need it. Cause I feel like sometimes people try to like over engineer stuff at the beginning. So like keep it as simple as you can. And then if that's not working, then see what you can add to make it work. As opposed to like jumping off the deep end. Like if you're new to all this and you're like, oh, I'm just going to use Git Flow. Well, yeah, like it's better than nothing, and it has some tooling, but it can be way overcomplicated for a lot of things. And there's also like this tension too between like creating all these feature branches, because when you create a feature branch, it's nice, you're working your own little bubble. But the problem is eventually you've got to integrate those changes anyway, right? And so there's kind of two schools of thought. And one is to like make these feature branches and do everything in your own little bubble. And the other one is to constantly integrate, continuous integration. And so constantly move your changes into the main branch. And so there's a tension there. So,
yeah, that's interesting. I could definitely, it's interesting.
Cool. I'm going to throw the link for my course in there just in case anybody's really interested.
Yeah. And I'll post this recording on our site. I'll try to include it in the newsletter as well. The link to the recording. And Sam, if you could put your information, there we go. I'll also post that if people are interested in Sam's class. I think that would be a great way to, learn this stuff and get some high confidence, especially if you have a team. I could, definitely see the benefit of taking a class and getting everybody on the same page,
Yeah. Cool.
All
right. I have another meeting in 1 minute. So
okay. Well, yeah, we're about done. So thank you everybody for showing up, and hopefully we'll see you at the next one.
All right. Thank you.
Yep. Take care.
Thanks everybody.
All right. Thanks. Bye.
Bye.
Bye.